So this is the setup for today. So we have the digital multimeter. We have some pen and paper to take some notes. We have here the PASCO RLC circuit. And we have the lab manual, the oscilloscope to visualize and measure the signals. And we have the function generator to basically generate some signals, and we are going to use today sine waves. So first step that we need to do here is basically to measure the values of the resistors. So we are going to use this 100 resistance, ohms resistance, and we are going to measure the resistance of this coil here. Okay, so we will open the multimeter, put it on ohms, and because we know it's 100 ohms and this one is inductor, so it's almost just a wire, a coil of wire, which means it has a very low resistance. Let's reduce the range here and make it ohms only, and let's get the probes for the multimeter. We have it here, so let's measure. So for this one it is 98.8 ohms. Write it down, 98.8 ohms, the resistance. And basically we need to measure the resistance of the coil, let's say RL. So we put here these two probes, and it becomes 5.7 ohms. So this is equal to 5.7 ohms. And let's connect the circuit. We are going to connect this capacitor, which is 330 microfarad, in series with this inductor, which has an inductance of 8.2 millihenry, and this is going to go in series with this resistance 100 ohms. So we have this connection and this connection at this point. So it's basically, we have here a capacitor of 330 microfarad. Then we have an inductor of 8.2 millihenry, is L, and we have here resistance, and this is equal to 100 ohms. So we have these two connections. We are going to connect the power supply from the function generator. So we finished using this digital multimeter. Let's put it aside for now, and let's connect the function generator itself. So here's the function generator that we are going to use. We connect the probe to it and we turn it on here, and basically we need to select the sine wave that we can see here, and let's put the signal itself inside. Let's put the positive at this location, and let's have this 100 ohms. So by now we have connected the circuit, and let's put the oscilloscope itself. We have two channels for the oscilloscope. So let's see the oscilloscope. We have channel 1 and we have channel 2, and we have these two probes. So let's connect them. So how do we connect them? We're going to connect them this way. The first channel of the oscilloscope is going to be connected here, channel 1. So basically connecting them here, we can have this one here. Let's see this location. Then let's connect the second top here, here. So we have connected the first oscilloscope or first channel, and let's use the second channel, and we are going to connect it on the resistance itself. So channel 2, and basically the voltage and the current, or the voltage that we are measuring here, is going to have the same angle as the voltage on ours. So the angle, okay, or like let's say this one has VR, and there's a current moving here, current in the circuit. So VR has same angle as the circuit current. Okay, so let's connect this one. The second one, I connected one here and one at the bottom. So right now this is almost the whole circuit setup. So for now we need to make this the function generator on sine wave, and we need to put only 15 hertz. So we have some buttons. You can see this one is amplitude, so we will press on amplitude. Let's make it 1 volt peak to peak. Then I will press the frequency, and then this one is like 2 kHz to 2000 hertz, but we need only 15 hertz. We press 1.5 and we select the hertz, so it is 15 hertz. Then we go to the oscilloscope, and we can see that the oscilloscope itself, it has the signal, the two signals. The yellow one is the total voltage, or the signal of the total voltage, and the blue one is going to be the voltage on the resistance itself. Usually you might not see this. You might see something that is too many signals. So we need to change the horizontal scale until we have almost 2 peaks or 2 cycles, like this one cycle, another cycle. And we can see that this one has 20 milliseconds per division. So the time duration between this dotted line, if you see this dotted line and this dotted line, this duration is 20 milliseconds. And sometimes this signal might be too big. So let's select one of them. This one, for example, let's make it too high. So we need to start to change the vertical scale and bring it down until we see a signal. So we see here the whole signal in front of me. Sometimes we only see one channel. This one is channel 1. You can see here this is channel 1. So we need to look for a button so that we can visualize the second channel. So here it's going to be this button. So we can see that at this point the second channel was visualized. So we have the 2 channel in this case. Something to note, that you need to put the channels at the beginning on AC. To do this, you click on channel 1 double times, and you choose the coupling AC, and you go to channel 2 and make the coupling as well AC.
Resistance slows the flow as heat, you'll see. Inductance stores magnetic energy.